in this problem we have a stone and a string, and the stone is attached in the string and we circle in a vertical one, and what they are asking, at exactly the stone is at lowest position, it has a velocity u, and when the string is horizontal position, it has a velocity v. Then they are asking what is the change in velocity. So, this is the question we ask. So, how to solve? First let us draw the picture. So, we have a string of length L, this is the length L and this is the lowest position. So, the problem says it is whirled in a vertical circle. Okay. So, exactly lowest position, it has a speed u, and we know that this is the vertical position, right, and what they told, when the string is at a horizontal position, which means what, this is a horizontal position, right. So, at this position it has a velocity v. So, what is the change in velocity with respect to this position? So, basically it is doing, it is not a horizontal circular motion, it is a vertical circular motion. So, definitely the gravity plays an important role, and to find out, of course, we can use Newton's second law, but instead of using Newton's second law, if we use the work energy theorem, that is more easy and more quick. So, we can use the work and kinetic energy theorem, which means what is work and kinetic energy theorem? The change in kinetic energy is equal to work done by the force. Here who is doing work? Of course, there is a tension force, there is a gravity, but tension is always acting this way towards the center point, and at all point the particle is moving perpendicular to the tension force. Tension will not do any work, only the gravity is going to do the work. So, the gravity, the work done by the gravity is calculated as follows. We know what is the work done, force into displacement. Here force is the gravity, so mg downward, but displacement, remember, it is going from here to here. So, in principle it is really the displacement is vertical, right. So, we know that force is downward and displacement vertical. So, the formula cos 180 is minus sign. So, the work done by the gravity will be minus mg L. Please understand, because the vertical, since the gravity is a conservative force, it only bother about, even though it is moving in the arc, right, but the vertical distance is the matter. So, vertical distance is how much distance it moves from exactly L distance. So, force into distance, minus sign is because of force downward and displacement upward. This is equal to of, when the particle is here or stone is here, of mv square minus of mu square. This is the kinetic energy. Of mu square is kinetic energy at lowest position, of mu square is kinetic energy at the string horizontal position. So, now I want to know what is the v. U is given from the problem. So, we can take it this v this side. So, of m v square is equal to half m u square my mgl, and we can remove this 1 by 2 m, because m is common everywhere, and we can remove this 2. So, that we will have a v square is equal to u square minus 2 gl, or v is equal to square root of u square minus 2 gl. So, this is the speed of the stone at this position, and what is the direction? It is very clear, u is exactly horizontal one, this is vertical one. So, I can, if you want, write as a velocity square root of u square minus 2 gl into j cap, because it is a vertically upward, and u is nothing but simply magnitude times I cap, it is horizontal. So, the change in velocity is equal to v minus u. So, straight away you write that root of u square minus 2 gl j cap minus u I cap. So, the magnitude, if you find the magnitude, So, square you have to square root of u square minus 2 g L plus minus u the whole square. So, we get overall this is a u square minus 2 g L, this is u square. So, this is the v minus u the magnitude. So, this is nothing but 2 u square minus 2 g L, because here also there is a 2 u square. So, option B.